All right, so in this video, we're going to go through a few different word problem examples that involve having to set up a quadratic equation and then use one of our strategies to solve it. What I would encourage you to do while watching this particular video is maybe pause it as we go, right after we go over the question, maybe attempt it on your own, and then if you get stuck, watch how we would do the solution, okay? So we'll do these kind of in two separate parts, a few examples in each video. All right, so in this first example, what we have is that the height of a circular arch is represented by 4h squared minus 8hr plus s squared is equal to 0. And they've told us that h is the height, r is the radius, and s is the span of the arch, all in feet. Okay? And they've given us a little diagram to go with it. Right? So we see this arch has this kind of rectangular spot here with a circular piece, right? They're telling us that this is like the radius here. This is the span of the arch, and all the way from the top to the bottom is our height, right? So that's what we've been given to start with. Now it's asking us how high must an arch be in order for its span to be 64 feet and its radius to be 40 feet. So we can use those values with our equation and substitute them in the correct spot, right? So we have been given that the span, so S, is equal to 64 feet. We've also been given that the radius r is equal to 40 feet. So we can plug those values into our equation for h, still unknown, h squared, minus Okay, so 4h squared minus 8 times h times r, which is 40, plus s, which is 64 squared, is equal to 0. Okay? And then we can start evaluating this where we can, right? Simplifying that quadratic. So we have that 4h squared minus 320h plus 4,096 is equal to 0. And what we've been set up with now is a quadratic equation in standard form that's set equal to 0, right? So that means we can apply a couple different strategies. We can try and factor it. We could use the quadratic formula. We could graph it to check our answer. If we wanted to, we could complete the square. Right? In this case, I'm going to do it by factoring. Right? So I'm going to first see that all these terms are divisible by 4, factor out the 4, and I'm left with h squared minus 80h plus 1,024 is equal to 0. Now I'm looking for my two numbers that multiply to give me 1,024 and add to give me negative 80. And after a little bit of searching, I come up with negative 16 and negative 64. So 4 times h minus 16 times h minus 64 is equal to 0. Right? And again, now that we have things that are being multiplied together to give me a height, or to multiply together to give me a product of 0, we know that one of those factors must be 0. So either h minus 16 is 0, meaning that the height of this arch is equal to 16 feet, or h minus 64 is equal to 0, h equaling 64 feet, right? Now, what we also need to take a look at here is, do each of these things work out in terms of the diagram, right? Are both of these answers valid, okay? So if you consider the span, okay, so we've been told that the span there is 40 feet, okay? If our span here is 40, all right? So if this is 40, and then we're saying that the height is 16, right, here, and we're saying that the radius has been given to us as 40, the span was 64. So the span was 64, radius 40. There's no way that that height is actually going to be able to work out to be 16. Right? So looking at that a little bit carefully, you can kind of figure out, all right, well, there's no way that if this radius is 40, right, that this height would only ever be a value of 16. So the 16 isn't a value that works, right? So it's not valid based on the diagram. Right? So instead we can say that the height of the arch would have to be 64 feet. Okay. Right, let's take a look at another example. So in this one we have to come up with our quadratic ourselves. We don't have anything given to us. So here we have the product of two consecutive even integers is 16 more than 8 times the smaller integer. Determine the integers. Okay, so again, we just kind of have to go through this piece by piece and just understand what everything's meaning, right? So remember that product means the answer through multiplication. Consecutive means one right after the other. And we remember that a definition that we have for even is 2 times a value, right? So if something's divisible by 2, then it's even. So we kind of start off with this little let statement where we say, let 2x be the smaller even integer. All right. Our next even integer, okay, and how we're going to get to the next even integer is by adding 2, right? So then we have our second let statement where let 2x be the larger, right? All right, be the next, and obviously larger consecutive even integer. Okay, so we have two numbers represented, right? So the first and the second even, represented by 2x. The fact that they're consecutive, it's 2x and then 2x plus 2. And they're saying that their product, okay, so meaning when we multiply these two things together, right, their product is 16 more than 8 times the larger integer, which means if we were, or the smaller integer, so if we were to take the smaller integer, which is 2x, multiply it by 8, and then add 16 to it, it would equal the product of those two things. Okay, so 8 times the smaller integer, so 8 times the 2x, it's 16, the product here, right, is 16 more than that, meaning we would have to add 16 to the 8 times 2x in order to get that same product. Okay, at this point now, we've kind of set up our equation. We can start expanding, right, to try and make this look a little bit more quadratic. So we get 4x squared plus 4x is equal to 16x plus 16. Let's bring everything over and set it equal to 0. So what we'll get is 4x squared, 4x minus 16x is going to be negative 12x, and then negative 16 is equal to 0. And this is, again, something that I'm going to attempt to solve by factoring. We start by factoring a 4 from all the terms. X squared minus 3x minus 4 is equal to 0. Right? Now I'm looking for two numbers that multiply to give me negative 4 and add to give me negative 3. And they are, of course, negative 4 and positive 1. Right? Which means my values of x come from when x minus 4 equals 0, or x equals 4, or when x plus 1 equals 0, and x equals negative 1. But what we need to do here is then plug these values back into my original let statements to get my values of my even integers, right? So if we use x equals 4, then my 2 times 4, my first integer is 8, and my next integer will be 10. Right? And we can check to see if that works. The product of 8 and 10, right, so 8 times 10, that's 80. 8 times the smaller integer, so 8 times 8 is 64, plus 16, right, so that's now 64 plus 16, which is 80, right? And we do get that those are equal. So these are the first two sets, 8 and 10. Or we can evaluate, well, what if x was, in fact, negative 1? Would that work as well? Well, then what we would get is that my first smaller integer is 2 times negative 1, which is negative 2, which is still an integer, right? Nothing here says that it had to be positive. And then we get my second integer is 2 times negative 1 plus 2, which is 0. 0 is still defined as even because it can be written as 2 times 0. Right? And again, if we check that, the product of those two things, so negative 2 times 0 is, of course, 0. If I take 8, multiply it by my smaller integer, which is negative 2, and then add 16, what I get is negative 16 plus 16, which is 0, so these options work as well. Right, so there's two solutions to this, right, in that the integers are either 8 and 10, or the integers are negative 2 and 0. Right? Had they defined the question, maybe it was only positive even integers, then we can disregard the second option. Right. So here, a third example for you. So a rectangle with area of 35 centimeters squared is formed by cutting off strips of equal width from a rectangular piece of paper that has dimensions of 7 centimeters by 9 centimeters. What is the width of each strip, and what are the dimensions of the new rectangle? All right, so again, let's start by perhaps drawing a picture here. Right? So what we have is a rectangle that has an area of 35 centimeters squared. All right. And that rectangle is formed by taking strips off of a larger rectangle. So really what happens is that this smaller rectangle here that has an area of 35 centimeters squared, it was created by having a larger rectangle and kind of chopping off this and chopping off this end and chopping off this end and chopping off this end, leaving us with this area of 35, okay? Now, it told us that that larger piece of paper, right, it's formed by cutting off strips of equal width from a rectangular piece of paper that has 7 by 9. So this larger piece of paper, we know the dimensions of. We know that these dimensions were 7 centimeters by 9 centimeters. And we know that the width of each of the strips is equal. So I know that this width is equal to this width, which is equal to this width, which is equal to this width. And again, they're being told that they're equal, and it's the thing that we're being asked for in this part about what is the width of each strip. So that's the variable that we're trying to solve for. That's the value of x. Okay? So now is the part where we actually have to try and develop a quadratic here. Right? So we actually know the area of our larger rectangle. Okay? So the area of larger rectangle is just length times width, and we've been given those dimensions of 7 centimeters by 9 centimeters. Right, so we know that that has a value of 63 centimeters squared. We know that the area of the inside rectangle, it was given to us, right, the area of the smaller rectangle was told to us as 35 centimeters squared, which means that the area of the strips that have been taken off, right, could be found by taking the larger minus the smaller, or what we could try and think of is that the area of that inside rectangle of 65 centimeters squared is found by looking at these dimensions, right? So this length here, right, versus this length here. So this length going across the bottom here, it was 9, but we've taken off two of those strips, right? So that area of the smaller rectangle of 35 would have been found by taking that length of 9 and subtracting those two widths. Then, the width or the height here, right, would have been found by taking the overall height of 7 and subtracting its two widths here and here, so 7 minus 2x, right? Those would be the dimensions of this smaller rectangle, right? This is 9 minus 2x here, and then this is 7 minus 2x in here. Right? And we know that when we calculate that area of length times width, we get an answer of 35. Right? And then this can then be expanded and solved. So we get 35 is equal to 63 minus 18x minus 14x plus 4x squared. All right, so bring everything over to one side. So 0 is going to equal to 4x squared. Negative 18x minus 14x, that's negative 32. X, 63 minus 35 will be a positive 28. Okay, and once again, I can see that all of those things are divisible by 4, so I'll start by factoring out that 4. Squared minus 8x plus 7. And then two numbers that multiply to give me positive 7 add to give me negative 8. They are x minus 7 and x minus 8, or x minus 1, sorry. And so that means that either x minus 7 is equal to 0, and the width is either 7 centimeters, 4x minus 1 is equal to 0, and the width of the strip is 1 centimeter. Now, it doesn't make sense in context for this width to be 7, because remember, the entire height of the original piece of paper was 7, so if you cut off that entire width, you're not left with any paper. So this doesn't make sense, but the 1 does, right? So the width of the strip, right, so the width of cut-off strips, I guess, multiple strips are being cut off, is 1 centimeter, which means that the dimensions of the new rectangle, right, that smaller rectangle with an area of 35, this length here is 9 minus 2 times 1, right, so that's going to be a length of 7, and this is going to be 7 minus 2, which is 5, and then that makes sense that the area would be 35 centimeters squared. Right? I mean, this was probably a question you could have solved just by guessing and checking and figuring it out and saying, well, it has to be, it has to be 7 and 5. And you're right, it probably could have been solved that way, but this is at least how you would set it up. And say it didn't factor and you'd have to use the quadratic formula, it would work out the same way. Okay? All right, let's do another just quick example. Let's go over some more challenging factoring, right? So this was the new stuff where we kind of had to use dummy variables, right? When we were factoring particular expressions, right? So in this first one in A, right, we have this 3 times 2v plus 3 squared minus 9 times 2v plus 3 minus 30. And what you should notice is that 2v plus 3 kind of shows up a couple times here. Okay, undo that. All right, so we see that 2v plus 3 shows up here as well as here. And this is where you create that dummy variable of, let's say, let w equal 2v plus 3. And now everywhere I see 2v plus 3, I'll substitute a w. So then what we get is 3w squared minus 9w minus 30. Okay? And then what you end up having is something that can be factored a lot easier. Right, we can see that each of those things is divisible by 3, so we get 3 times w squared minus 3w minus 10, and then you can factor that, and then that gives us 3 times w minus 5 and w plus 2. And once I've factored it that way, I can substitute back in what my dummy variable was, so you get 3, and then put in for w 2v plus 3 minus 5, and 2v plus 3 plus 2. Simplify inside your brackets. You get 3 times 2v minus 2 and 2v plus 5. And look inside your brackets and see if there's anything else that can be factored. And in this case, you can, right? In this one here, 2v minus 2, there is a common factor of 2 that can also come out. So what you'd have is 3 times 2 times v minus 1, and then your 2v plus 5. Right? And then this 3 and this 2 can actually just get multiplied together to give you 6. So what your fully factored form is 6 times v minus 1 times 2v plus 5. And we're not solving this equation, we're just trying to fully factor it, and that's where we would be, as fully factored. Okay? And we'll just do one of the other examples here. Let's take a look at C. Okay? So here, if we have 1/9 y squared minus 1/3 yx plus 1/4 x squared, again, that looks a little bit challenging, but first let's take out essentially like a common factor, okay? So each of these things, if you looked at like a common denominator for 9, 3, and 4, you'd actually get 36. And you can actually factor out that fraction of 1/36 and be left with 4y squared, right, minus 12yx 12yx, 12yx, and then okay, yx I think we're having some serious technical difficulties here, and then plus 9x squared. Okay, and that's when you're dividing everything by 1/36 to get that to factor. And then what you can see is that You can factor this by decomposition still, just by looking at your leading values, right? So that 4 multiplied by that 9, you get 36. What are two numbers that multiply to give you positive 36 and add to give you negative 12? They are negative 6 and negative 6. So you just leave that 1/36 out front. You get 4y squared minus 6xy minus another 6xy plus 9x squared. Do factor by grouping. And you've got a common factor in these two of 2y, and you're left with 2y minus 3x. And then looking here, you've got a common factor of 3x. So you can factor out a positive 3x here, and inside you get positive 2y plus 3x. Right? And then once again, you can see that your common factor was 2y. Oh, that's going to be a negative 2y here.
It'll be a negative.
Yep.
It'll be a positive 2y, but it'll be a negative 3x because you have to factor.
Yep, so we've got 2y and then 2y minus 3x, and then if I factor out a positive 3y, I'm actually going to change this and factor out a negative 3x so that that actually becomes a positive 2y minus 3x. Then we get that common factor of 2y minus 3x and 2y minus 3x again. So this is actually a perfect square polynomial. Right, and then this is considered now fully factored. And you could simplify this just a little bit. It's 2y minus 3x all squared. And we will cut that there to shorten the length of the video.